Hi everybody, my name is Timothy De Win, and with me I have Sander Berkouwer. He's a Microsoft MVP and an expert in Active Directory. Now this is our second session in our AD series, Active Directory series. So we already covered the Active Directory basis. If you want to know more about that, if you want to go back to the basis, you can go to our website, veeam.com. Under the resource menu, you'll find the expert webinars, and there you will find the first session of the Active Directory series. In this second one, we're going to cover Active Directory and virtualization. So Sander, with that, I'm going to give you the word and let's get it going.
Yes, let's get this started. Yeah, we're going to talk about some basic stuff about Active Directory and virtualization. I'm going to cover the current situation and why we want to and why we virtualize domain controllers. And then I'm going to talk about challenges. So the challenges that we face when we're virtualizing using Hyper-V and the challenges we're facing when we're virtualizing using Azure Infrastructure as a Service. That will be the first half of this hour. And the second half of this hour, we're going to walk through some of the solutions in terms of technology, but also processes and people that Microsoft offers for every specific challenge. And I feel that is important because we could just talk about technology, and I see a lot of people do that, but technology is just one piece of the puzzle. You can have the most brilliantly implemented technology fail because of processes that are missing or people that are misbehaving. So you have to stack the three and together to make it successful. So that's why I'm going to focus on the issues, the challenges that you might have with people, processes that we need to have in place, and a technology that can actually help you tackle any issue that you might have. So without further ado, let's talk about the current situation. And in the current situation, we tend to focus on the benefits of virtualizing domain controllers. And the benefits are large. We virtualize domain controllers because we want to get domain controllers fast. If you want to have a physical domain controller, go ahead. Try and purchase a server, go through purchasing department, get a financial approval, then get the stuff delivered to your doorstep. If you didn't buy it as a whole, you have to assemble it, then you have to install Windows Server on it. If someone from the supplier hasn't already, then you have to put it in your data room and start it up and then promote it to a domain controller. In a virtualized environment, what you'll see is that if you have a template for a Windows Server VM, it's just 5 minutes to provision the server, 4 minutes to start it up, 3 minutes to make it have a fixed IP address and DNS and stuff like that, and only 2 minutes to make it a domain controller. You could be done under 15 minutes. That's a huge difference, and that is why we love virtualizations. Again, the hypervisor and virtualization software offers more benefits because domain controller VMs are no longer tied, or domain controllers are no longer tied to specific hardware. So if you have a failing component in a server, like a failing ventilator, you could just move all the VMs off without downtime. VMware invented it, but Microsoft also has a live migration. You can just move a virtual machine while it's running from one hypervisor to another one, and then fix the failing or the faulting component, and then boot it up and move virtual machines back when you feel the machine is reliable enough to actually host the VMs like domain controllers or just some test and acceptance environment. Now, of course, virtualization is also about cost saving and cost predictability, because virtualization increases hardware usage. If we talk about domain controllers, what you see is that Microsoft has a recommendation to have your operating system on different spindles than your Active Directory database, your Active Directory transaction log, and your system volume, your sysvol. But in a world where the smallest disks you can actually purchase for a server are 300 gigs in size, not many organizations are gonna need 300 gigs of storage space in a RAID 1 volume for their database and system volume. Most organizations I know are fine with just 300, 400, 500 megs instead of gigs. So there's a lot of spindles that are just there and most of the time aren't used, just over-provisioned. In a virtual machine, you can have fixed disks, you can have a thin provisioned disks. Of course, don't do that with your Active Directory database, but it's more optimized. And also, if you're talking about physical domain controllers, what you see is that hardware maintenance and hardware upgrades are difficult. If you have a domain controller that is struggling because it is underperforming in terms of the components that are in the box, then you would want to upgrade the box. But you can also only upgrade it so far. So if it is a box with 2 processors, then you can't add a 3rd processor. Or if it's a box that can only hold 32 gigs of RAM, then you can't up that to 64 gigs of RAM. You have to create a whole new domain controller. With virtualization, you can add and remove software and hardware on the go. It is not a problem. And that way, you can reduce hardware-related outages. Now, in a well-designed Active Directory environment, any outage of any domain controller isn't much of a problem. But yet, you want your Active Directory to remain stable and reliable. Because there are some components in Active Directory that you cannot make highly available that easy, like DNS, DHCP, that's all that IP-related stuff. When we virtualize domain controllers, we gain another big benefit if we have domain controllers that are running Windows Server 2012 or up. Because if your domain controllers are running Windows Server 2012 or Windows Server 2012 or 2 or Windows Server 2016, Active Directory is virtualization aware. A domain controller running each of these operating systems is able to detect when a snapshot has been applied or when a virtual hard disk is being reused for a different virtual machine. And instead of making that a problem, Microsoft has made it a benefit. They saw the opportunity to say, you know what? If you got a virtual domain controller, if you have a VHD or VHDX, whatever, you copy it, you make a new domain controller, and all domain controllers are 99% equal anyway, you know what? We're going to give you the ability to create a new domain controller by cloning the domain controller. And there's a certain stuff that you need for that. So you need the Veeam generation ID, which is a feature from the virtualization platform. And what it does, it places a Veeam generation counter value in the memory of each virtual machine that runs on the hypervisor platform. And Active Directory was the first solution to take advantage of that value, and it stores that value in Active Directory. And for every major write operation in Active Directory, it actually compares the 2 values to see if nothing has changed. But if a snapshot is applied or a hard disk is being reused, then you get a different Veeam generation ID. And then Active Directory compares the 2 values and says, you know what, something changed, we're going to fix it. We're going to either perform some database management to see if we're up to date, or we're going to clone to make more domain controllers. And it's funny because in the first session of this series, we talked about the snapshot and how domain controllers aren't really able to tell time, and domain controllers aren't really capable of moving back in time, because that was a scenario that was never envisioned for Active Directory back in 1997. But these days, with virtualized domain controllers, this is one of the benefits that you get. But you need the Veeam generation ID, so let's see what that looks like. Because I still got a virtual domain controller on this system, so we can look at that. Let's see. So this is that domain controller.
By the way, Sander, we already
Yep.
had a question in the meanwhile. By the
Cool.
way, if you have questions, please do not hesitate to put them in the question box. So somebody is asking, so wouldn't it be best practice? So if I have one virtual machine that is an Active Directory server or domain controller, wouldn't be it a good practice to put another one on a different host on local storage? I guess that could help for HA, but it just all in the design, right?
Yep. Yeah, there's many ways to design a solid Active Directory using virtualized only domain controllers, using both virtualized and physical domain controllers, and using just plain old physical domain controllers all along. Yep.
So it's a bit of common sense to create a highly available environment, whether it's virtual or physical. Okay,
Luckily today, yes. Yeah,
yeah.
but it didn't used to be that way.
Okay, so is it okay to do an in-place upgrade of a DC from 2008 R2 to 2012 R2? I believe that's possible.
Yes.
You cannot go directly to 2016 even from 2008 R2. I'm not sure, but that's possible from 2008 R2 to 2012. So, okay, continue.
Yes. So what I was going to show you is the VM generation ID. So this is a virtual domain controller. It's called DC1, and it runs on Hyper-V on Windows 10. It's funny because both Windows Server and Windows have the same Hyper-V version. So most of the stuff that you'd normally do on a Hyper-V server or on Windows Server with Hyper-V, you can today do on Windows. So the best way to look and to see if a machine can benefit from VM generation ID is to see if there's a VM generation counter as a device. So for that, we're going to Device Manager, which is right here. After I right-click my Start button, and we have to have the hidden devices shown. So I'm going to show hidden devices, and now if I expand the system devices, I can actually see the Microsoft Hyper-V generation counter. And this guy, I can double click it if you go to Details, and then you have some values right here that compose the generation ID. So it isn't even that interesting actually to know what the VM generation ID is, but you could figure out if you wanted to. Since we have the Microsoft Hyper-V generation counter device in Device Manager, we can safely say that we can clone this domain controller. But there's some more stuff that we need to do. So for instance, one of the other things that we need to do is to check if this domain controller doesn't have any services or application that are not tested by Microsoft for DC cloning. And luckily there's a PowerShell command for that, and it's a pretty long one, but luckily Windows PowerShell offers tab completion. So I'm just going to type get dash a double D double C and then tab. And it's to get AD DC cloning excluded application list. And when I run this command, it will give me all the applications and services that Microsoft didn't test, that you have to test yourself or have to Google or Bing, whatever, to make sure that it supports DC cloning. So there's some stuff right here that we need to check. And if we're sure that we're going to whitelist them, the command itself is able to create the DC cloning excluded allow list, which is an XML file that does that. Unfortunately, I don't have any time for that during this session, but I do have time to show you one other thing, which is stored in the Windows and then System32 folder, which is the sample DC clone config.xml file. And this is actually the file that we feed a domain controller, either by placing this file in the NTDS folder, we've discovered that in the basics as well, or on a virtual floppy drive or a removable media drive to a domain controller. And this file, Internet Explorer is not going to be able to do anything with it. So I'm just going to open it with Notepad because that'll make sense. This file is actually the file that we use to tell the new domain controller to do whatever we want it to do. So what you see here is that, of course, it's a new domain controller. It needs a fixed IPv4 address and perhaps even some fixed IPv6 addresses. Then you can have a default gateway, DNS resolvers, and even some Win servers if you still run those. And when we supply this file to a domain controller with a reuse disk, during startup, it will see the DC clone config allow list of application allow list. It will see the DC clone config file, and it will see, you know what, if I look at the allowed list, the whitelist, and I see what I have to check, then there's no gap anymore. So there's nothing holding me back to clone. Let's look at the DC clone config file now and see what my new network values are going to be and use those. So within approximately 5 to 10 minutes, you can actually have a second domain controller running just like that. And that is easy for disaster recovery and for forced recovery scenarios. But oops, I just talked about disaster recovery. I'm sorry, I shouldn't. Really, I shouldn't. That's the topic for the third session. So instead, let's look at challenges. Because there are some challenges when you're using Hyper-V and Azure IaaS. So in Hyper-V, what you could be worried about is performance. So yes, if you have a virtualized domain controller, it will run slightly more inefficient than a physical domain controller. It's about 3% is what Microsoft has calculated. And it's about right. Now, if you have nested virtualization, so you have a VM that is running in a VM that is running on a physical host, then you have some more impact. It's about 9 or 10%. But it's the levels of performance lag or performance gap that you'll be seeing. It's not much, but in really stressful situations, for a domain controller that is, not to me, but for a domain controller stressful situations, you'd want to have optimally performing domain controllers. The other thing that we might have a challenge with is the integration components. And the integration components are really great pieces of software because they enable us to do host-based backups, they allow us to do time synchronization, and all the stuff that domain controllers really like. But on the other hand, there's a security issue there because from the hypervisor, you actually control the virtual machine. And from a domain controller or an Active Directory point of view, that might not be what you want. And if we're talking security anyway, then let's recall the recommended practices that Microsoft used to have 10 years ago and still has for physical domain controllers, where they're saying, you know what, if you have a domain controller, restrict physical access to it. Place it in a server rack with a lock on it, in a data room with a lock on it, with a camera on it, and make sure only people that you want to have access to the box. Because if you have physical access to a domain controller, you own that box. It's just like a Windows client. How do we do that with virtualized domain controllers? That's an issue. And then, of course, a Hyper-V admin has the most powerful tool to wreck Active Directory. It's Hyper-V, or it's vSphere. Because if you refer to a snapshot and it doesn't have VM generation ID, then you can actually break replication right there. You do it once, it's not that big of a problem. You do it twice, ooh. You do it 3 times, your Active Directory is mostly broken. So you don't want that. Backup and restore, if done awfully wrong, it will wreck your Active Directory. And then there's a trust issue that you might have. Now, personally, I have issues with Active Directory trusts, but you can also have issues with trusting your Hyper-V administrators and your storage administrators. Yes, Hyper-V administrators can stop your domain controllers, can start your domain controllers, can revert them, can restore them, can access the disk. You might not want that. And storage administrators, they can just copy the disk out and do whatever they want with it, which includes copying off the database and trying to guess anyone's passwords without you as an AD admin ever knowing. Now in Azure IaaS, we have different challenges. So if you have domain controllers running in Azure Infrastructure as a Service and you have your clients on-prem, then you might wonder about the connectivity and is it enough? And is the standard site-to-site VPN solution that Azure offers, is that good enough for your situation? Then of course, Azure does things totally different than you would on-prem. There's other stuff. There's the cloud service if you have the Azure IaaS v1. There's the load balancers. There's the traffic manager. There's all that stuff that is different in Azure IaaS than the stuff you have on-prem. So if you want to have domain controllers in Azure IaaS, you need to know the taxonomy and the topology of Azure IaaS and how it works. Because if you change the IPv4 address on a domain controller that is running in Azure IaaS, just in the GUI, you will break it. It will no longer have connectivity. So that's something that you don't want to do. You can assign it a static IP address. You can assign it another IP address. Just don't go fiddle in the box's IP configuration like that, because that breaks it. And all of a sudden, a couple of months ago, Microsoft has decided to call every virtual machine that was running in IaaS v1 in the Azure Service Management model, they decided to name them classic virtual machines. Well, that's a classic joke. But that's because they created a new Azure IaaS version 2 based on Azure Resource Manager as a model. And you can now have virtual machines that have multiple network interface cards, for instance. So yes, the IaaS v1 are now classic VMs, and they will soon be obsolete. So Microsoft has tools now to migrate those over from v1 to v2. And under the hood, of course, Azure IaaS uses Hyper-V. You don't know the Hyper-V admins. You don't know the storage admins. Heck, you don't even know what storage they actually use. And if all that stuff is missing, and if you have legal requirements to do so, will you ever be able to report on a breach? How does that work? Around this time, you might ask yourself, why is that important to me? Well, I feel it is important to you because Active Directory suffers from advanced persistent threats. If you look at the breach at Sony, if you look at the breach at Target, but also many, many other breaches, we're seeing past the hash attacks, past the ticket attacks, Guro's golden ticket attacks, skeleton key attacks, you name it. That stuff happens all the time. And you want to have the technology and the processes in place to counter those. And what about people? What about rogue admins and disgruntled admins? I mean, AWS was down last week because of a rogue admin. And of course, that's a bold statement. But in my book, every admin that doesn't work following a process that doesn't let his commands be code reviewed is a rogue admin. If there's no 4 eyes watching everything that we do, the chance of rogue actions is really big. And the potential damage is also pretty big. So you want to contain that. And in terms of security, you know, many organizations have legal requirements that actually tell you to, well, you know, the basic stuff, backup, restore, monitoring, auditing, all that stuff. But you have to do it. How do you do that with a virtualized domain controller? And if we're talking about security, then there's one security that is the most important to any one of us, and that's job security. You know that if things get horrible around Active Directory and you're responsible for that stuff, that's your job on the line. So you don't want that. And it is really easy. I was talking to Benjamin Armstrong. He's the principal program manager for Hyper-V. And I told him, you know what, could you give me a quote that actually makes it really easy to understand how dire this situation is. And he said, you know what? If you can Control-C and Control-V, then you can hack VMs running on Hyper-V. And it's funny because it rhymes, but it is also really confronting, because for a Hyper-V admin, it is that simple. If I see a VHD, I can just copy it, double-click it, and say, you know what? This is now my virtual machine. You can just see the contents of the virtual hard disk. You can just copy off the ntds.dit. And because you're doing that in a copy, you will never see anything in the audit logs on your virtual domain controller. And just a reality check. Because let's face it, Kerberos isn't that big of a protocol anyway. So in Kerberos, and let's dive a bit into Kerberos, not too deep, but just slightly. If you have a computer that starts up or a user account logs on, what you'll see is that you will get a ticket granting ticket, a TGT, from the Key Distribution Center, the KDC. That is the RFC term, the official term, and Microsoft made it a domain controller. And that's the KDC implementation of Microsoft. Now, when you access the service, like a file server, then what you have to do is ask the domain controller using your TGT for a service ticket. So now you get a TGS, and that's the kind of stuff that you can send to the file server, for instance. And because it is signed with the same key that was used for the TGT and the same key that is used by the domain controller, the file server will know that it is trusted. It can just trust the packet because it is signed with the one secret that is in Active Directory. So what do you think an attacker is going to want to know and is going to want to compromise in your Active Directory? That's right, that one key. That one key. That's the key to the kingdom. And it's funny because there's an account in your Active Directory. There's a kind of never runs Active Directory. It's called a curb TGT account. It's in the user's container by default. And it's disabled by default anyway because you don't want to have to log on with it. Its password is just used to sign everything that is Kerberos related. And if you have the curb TGT password, you don't have to play nicely with domain controllers anyway. If you have the secret to encrypt TGTs, you can make your own. Your TGTs and TGSs are all client-side enforced. And if I say client-side enforced, what you should hear is, it sucks. Because it does. Now, luckily, you can have read-only domain controllers, and I'm going to go over those in a bit. They have their own curb TGT accounts. So that minimizes the impact. And if I can make my own TGT, of course I'll insert well-known SIDs, like the group SID for domain admins or the group SID for enterprise admins or schema admins, stuff like that. And I'm not going to play nice anymore. So even if you have a TGT lifetime by default of 10 minutes, I can still make it 10 years because according to the RFC, that is how long I could make it. So I am gonna. Luckily, the authentication policies in Windows Server 2012 are a bit more of a mitigating factor. But you should ask yourself, not just for virtualized domain controllers, but for physical domain controllers as well. Do you know all your domain controllers? For instance, do you still run Windows Server 2003 domain controllers? And if you do, please get rid of them because these servers are highly vulnerable and they don't get patched anymore. And if you have physical and virtual domain controllers, are you absolutely sure these are physically secure? And if you can say that, are all their backups physically secure? Because if I want to do bad stuff in your organization and I can see that all the domain controllers are secure, I'm going to target backups. You bet. And talking people, it's important to know who is your organization's admins. And I often go to a customer and ask them, so who's the enterprise admin? And they say, yeah, well, let's look at the enterprise admins group. And they say, you know what, these are the members of the enterprise admin group. And I say, no, what I specifically asked is your Active Directory admins. So your hypervisor admins, your storage admins, your backup admins, and your AD admins. Those are your Active Directory admins. And if we're talking processes, then you could ask yourself, do I regularly reset the kubectgt's password? And I'm going to go over that in a while, because I got another slide on that. And if you use install from media to deploy domain controllers at branch offices, because you only have small bandwidths, how do you physically secure the install from media data? Because that contains the same keys to the kingdom. And if you are asking questions, why not ask them here? Timothy, are people asking questions?
I think at this point they are still a bit overwhelmed by all the Kerberos stuff. So no, there are no new questions, but please, if you have any questions, don't hesitate, put them in the question box so we can interactively answer them. Okay, there we go.
Yes, because yeah, I can see why this is a bit confronting to people. So that's why we've spent the last half hour looking at the challenges and the questions that we should ask ourselves as AD admins, as admins of virtualized domain controllers, as admins of physical domain controllers. So let's stop that and let's look at the solutions that Microsoft have. Let's look at the technology that Microsoft actually gives us to secure domain controllers, to secure our Active Directory, and to make everything run smooth and makes us get out of the woods and just enjoy life again. You know, manage Active Directory from the beach, for instance. Why not? We've got job security. Why not enjoy life a bit? So let's start with the reset kubectgt secret. This is something that Microsoft has been aware of for the last 10 years. I saw people reusing kubectgt secrets about 10 years ago on TechEds. And since January of 2015, Microsoft, or February 2014 even, Microsoft has a solution, it's now 3 years in place, that allows you to reset the kubectgt secret. And it's funny because if you look at it, if it's the key that is the secret for all packets, and there's a maximum lifetime on all the maximum permitted lifetime on all those tickets, then I shouldn't just be changing the secret and be done with it, because everyone's session will be invalidated. So Microsoft made the kubectgt account use two secrets. There's one active secret, and if you ask for a new GGT or if you ask for a new TGS, you use the new key, and there's a fallback key. And if you create a new password or new secret, the old secret becomes a fallback secret. So that's why you can just reset the kubectgt secret without any problems. But you'll also find out that if you are going to reset the kubectgt secret, you're going to have to do it twice. And you're going to have to wait between the 2 points, because a kubectgt, a Kuros TGT ticket, can be renewed for a week. So my recommendation is to keep 2 weeks between resetting the kubectgt secret. You have to reset it twice. Now there's a script from Microsoft on the TechNet Gallery. I'm just going to click the link and show you, because it's a free download. You can just use it. And it has a description, it has a Q&A. You can just use it for that purpose. Now the other stuff that I already talked about is the read-only domain controllers. And read-only domain controllers are a real piece of work. So a read-only domain controller only has a read-only Active Directory database. It only has a read-only DNS zones. So you can just read and authenticate and do all the stuff that you normally do. But if you want to change your password, or if you want to change or update the DNS record, you get referred to a read-write domain controller, or what we usually refer to as just a domain controller, just a normal one. It also has a filtered attribute set, and it has a sync list. So if you have a read-only domain controller, you can specify the user accounts that you actually want to be able to use and cache credentials for on the read-only domain controller in the branch office or in the DMZ. And it will then be pushed out from any read-write domain controller to the read-only domain controller. And if the box gets compromised for any reason, you just right-click in Active Directory on the read-only domain controller, specify that it is compromised, and Active Directory will tell you what accounts will be required to reset their passwords to become safe again. So yes, it is a recommended practice not to replicate any admin accounts to a read-only domain controller. And the other trick that a read-only domain controller has up its sleeve is the administrator role separation. So if you have a domain controller in a branch office and you trust the administrator to do the right things in terms of backups and in terms of driver updates and Windows updates, but you don't really trust him enough or her enough to be able to manage Active Directory, a read-only domain controller is a perfect solution because they can't do anything in Active Directory. They have to go to a read-write domain controller to do that. So yes, it makes perfect sense to have them. And they have their own corrupt TGT accounts. Unfortunately, because they have their own corrupt TGT accounts that they use to sign all the packets with, there's only one read-only domain controller supported per branch network. You can't have that highly available for a branch office or a DMZ. That is just not supported by Microsoft. If we're really talking people here, then one of the other things that you want to do is behavioral analytics, because that is the way to identify advanced persistent threats like the pass the hash, pass the tickets, skeleton key text, stuff like that. And Microsoft has a solution for that. It's the Microsoft Advanced Threat Analytics. It's part of the EM plus S suite. It's a subscription that you can buy into. And Advanced Threat Analytics, or ADA, is the on-premises solution for access management analytics. And it sits on your domain controllers. Or if you have Hyper-V, you can use port mirroring. And what you do is you feed all the packets that flow in and out of your domain controller to the solution. And then the solution itself has some filters and some mechanisms and some analytics just pre-enrolled. And it will just go through the packets and see what's happening. But if you opt into that, you can also use the cloud-based analytics based on Azure Machine Learning. And if you do that, you will actually feed the big Microsoft machine learning algorithms what's happening in your environment so they can develop filters for advanced persistent threats that at this moment nobody knows anything about. And of course, if a solution like that becomes available, you'll be one of the first ones to actually use it and benefit from it. On the cloud side of things, Microsoft offers identity protection, and every logon that you do to your Microsoft account, just not today, but okay, and your Azure AD account goes through a set of filters, about 92 of them, and you can have options like that to allow or disallow people using, I don't know, devices connected to the Tor network or iOS and Android apps, devices that are rooted. You can just specify them not to talk to anymore. And that will give your security point of view some real solid body. So that is analytics, and that helps. Talking people again. Go ahead, Timothy.
Okay, we have some questions. So somebody asked about the gallery script. If we have the link, I put it in the chat box. So if you want it, it's there. Somebody's asking, I'm just going to refer to it like the Kerberos TGT account. How often should we reset it?
I think yearly is a good measurement.
Okay. And so what about the existing users or the existing sessions? What happens to them?
Well,
when
if
you
you,
reset the account.
yeah, so if you reset it, then just once, then nothing happens. But for an attacker, nothing happens as well, because there's a fallback secret. So if you want to lock out any attacker using a golden ticket, then you'll have to reset it twice. If you reset it right after the first time, you'll invalidate each and every one session. Everyone is just going to have to log on again to gain their full functionality. So you have to wait just a week or at least 10 hours to change them both.
Okay, and we got a good question. I think we also covered, or we talked a bit about it in the first one, but I'm just gonna put it in again. So is a read-only domain controller a very good solution for remote office? Will it speed up the login and so on? I think we covered that a bit in the first session. So yeah, our read-only domain controllers do make sense in branch offices. And
Absolutely.
yeah, and what about analytics for VMware, both on-premise and in the public cloud? So I think it's not really about the Hyper-V that you were talking about. It's more about Active Directory, so you could also run it in a virtual machine on vSphere. Or am I wrong here?
Absolutely. No, absolutely. You can do that. Port mirroring is also available for vSphere. Yes, we've implemented that a lot of times already.
Okay, so that's it for the questions for now.
Cool. Let's dive on. Because we were talking people, and I just shut down my domain controller because I need that for a further demo, and we're a bit short on time. But let's look at server core and nano server. So in the first session, we already covered that nano server, unfortunately, currently does not offer the ADDS role, so you can't make it a domain controller. But you can use server core domain controllers. And because they don't have a graphical user interface, it is less susceptible to human error. If you want to do something on a server core host, you actually have to do it using a command, and that can be code reviewed. It also has less vulnerabilities, so you don't have to patch it that much. Now in 2008 and 2008-02, you have to choose at installation point if you wanted to have a server core installation or a full installation. But in 2012 and Windows Server 2012-02, you could actually strip the graphical user interface elements from a full installation and make it a server core, or re-add it to a server core and make it a full installation again for all those nitty-gritty application settings that you have in some graphical user interface somewhere deeply buried inside of the configuration instead of some neat and handy config file. Now, Windows Server 2016, unfortunately, we're going back to the 2008 and 2008-02 model for a good reason, but it's beyond scope for this session. And you have to choose that installation again. And you have to choose a normal installation or the installation with the desktop experience. And of course, the one with the desktop experience is the full installation, and the one without it is more or less a server core installation. So yes, if you have Hyper-V hosts, I can only recommend to deploy it as server core or as Hyper-V server, which is the standalone server core installation with Hyper-V enabled on it. Even though if you do implement a server core installation, there are still loads of ways that a Hyper-V admin could actually wreck your domain controllers. And that is because they have full rights on the VHD and the VHDX files. Because the default access control list allows administrators, system, and Hyper-V administrators full control. And the VM itself only has read and write access to its hard drive. So yes, you can just strip off administrators full control, strip off the Hyper-V administrators full control, and then you'll know that you'll still have backups, you still have the ability to restore because system has full control, but administrators won't, at least for a little while, because in Windows, an administrator can always take ownership of files and folders. So this is not a good way to lock out an administrator. It is a good way, if you want to lock out Hyper-V admins. And Hyper-V admins is a new role. It was introduced with Windows 8 and Windows Server 2012. And it's a new security group that is local to hosts with Hyper-V on it. You can actually configure accounts on Hyper-V hosts to no longer be an administrator, but just a Hyper-V admin. And that way, sure, you can't do certain stuff like running Windows updates, and you can't do stuff like updating drivers and stuff like that, but you have full control of the Hyper-V features. And then you still have full control on VHD access. So if that is a situation that you find yourself in, that you just want to restrict the Hyper-V admins, then this is a good way. Does it make your virtual domain controllers more safe? Not so much. Then there's the integration components, and we've covered them slightly already. And the integration components are the drivers and services for VMs, and they enlighten virtual machines. They let a virtual machine know that it's a virtual machine. Now, for Windows servers on Hyper-V, it's easy because the integration components are already part of the operating systems. If you run Windows servers on vSphere, you actually have to install the VMware tools. And on Xen server, you have to install the Xen tools. But you can do that, and that way you can enlighten the virtual machines. And it offers big benefits, like the ability to do an operating system shutdown, or to perform time synchronization if you want to. You might not want to with the main controllers. It offers data exchange, a heartbeat, to just make sure that the box is still running, and backup and guest services. And I've got a screenshot of the integration components for a normal box right here. And if you look at Azure Infrastructure as a Service, then of course Azure uses integration components as well. And they're a tad different than the ones that we find in Hyper-V. Because the ones in Azure IaaS, for instance, allow you to reset the local admin password of a VM running in Azure IaaS. And that's funny because there's a local admin password in a domain controller, and it's the built-in administrator password that you can reset. Luckily, the feature is only available for global admins, but the delegation model in Azure isn't that mature yet that you could actually restrict the global admin to just a bunch of people, because you need global admin rights for, well, a big number of tasks in Azure AD and in Azure. So that is a bit difficult to pull off, but you could. Then there's Timothy.
Yeah, we have some questions. So somebody's asking, what about antivirus on the Hyper-V host? Do you have any good or bad experience with that?
I only have good experiences with anti-malware solutions on domain controllers.
Okay, and then somebody else is asking, so what about my Hyper-V host itself? So if it's server core, would you join it to the domain? Or would you leave it as a standalone host?
So it depends. So if you're a small shop with just 1 or 2 or 3 Hyper-V hosts, then you could get away with not making them part of the domain. If you're a larger organization with a bunch of Hyper-V hosts, yeah, it makes sense to create a different Active Directory domain than the production domain and join your Hyper-V host to that, or just add your Hyper-V host to the domain running in VMs, because Hyper-V has a solution for that now, that it won't lock up when it starts up from a brownout, for instance.
Okay, and then somebody else is, and they're referring to your screenshot, and that's a very good question actually. So we have time synchronization with the integration services or with the VMware tools. Should we enable that for the Active Directory servers? Or he's saying, well, I read everywhere that I should disable the synchronization actually.
Yeah, so Microsoft has 3 different recommendations for that setting. And it doesn't really matter, because a Hyper-V admin or vSphere admin can just change it, enable it, disable it whenever he or she wants it. It's the same with a vSphere admin. Microsoft has gone to great lengths to make sure that the option itself doesn't hurt Active Directory that much, because Active Directory has its own time synchronization. So as long as your Hyper-V host and your hypervisors are not off by more than, I don't know, a month, you'll be fine.
Okay, good, that's it.
Cool, because we're getting to the good stuff now. Because we're going to look at BitLocker drive encryption. And there's support for virtualization hosts. So your Hyper-V host, you can just enable BitLocker for the boot and the system volumes. The whole host will just be, everything on a disk will just be encrypted transparently to the operating system. And further on, you can just apply BitLocker to cluster shared volumes. So if you have a Hyper-V cluster, you can actually encrypt everything that is on storage and just make it accessible to just the Hyper-V hosts. So that kind of takes care of the storage admins. But there's also support for BitLocker drive encryption in virtual machines. And the data disks are supported in Hyper-Vs for ages, and it's supported in Azure IaaS as well. But if you want to enable BitLocker on boot and system volumes, you'll have to use Windows Server 2016 or Windows 10 or vSphere 6.5, which has just been released. And in Hyper-V on Windows Server 2016, you can enable BitLocker for Generation 2 virtual machines. We will use the VTPM, the virtual TPM chip for that, or the Generation 1 virtual machine, which enables a certain device that will be locked to a VM, a virtual device, like a virtual floppy drive. And support in Azure IaaS, luckily, is coming soon. So soon you'll be able to encrypt the disks of your virtual machines. It's funny though, because we were talking integration components earlier, and data encryption, because it's transparent to the virtual machine, is not a solution, because it'll be transparent for the integration components as well. So there's another solution, one that goes beyond BitLocker drive encryption in Windows Server 2016, and it's the shielded virtual machines feature. And shielded virtual machines, the feature offers a lot of benefits. So yes, it offers separation between workload and fabric admins. It also offers attestation. And it also offers limited integration component functionality. So there's two certain ways to use shielded virtual machines. You can have the hardware trusted attestation mode based on the TPM version 2 chips in hosts, based on attestation, based on secure boot. So each and every Hyper-V host has to talk to a special service, the host guardian service, that Microsoft recommends to build upon free servers. And so every time the Hyper-V host tries to start a VM, it has to talk to the host guardian service, has to explain that it has secure boot, that it's not been compromised, and then the host guardian service will give the secrets to the VM, to the TPM chip of the host, so the host can start the VM. And through the virtual TPM feature, the VM itself gains the keys for BitLocker in the virtual-based security layer of the virtual machine that it can then, through the standard APIs, gain access to in virtual-based security. So neither the Hyper-V host nor the virtual machine, the virtual domain controllers, actually have access to the keys themselves. Those are stored in hardware. And then there's a second mode, and it's the administrator attested mode, and it's based on AD group membership. So for that mode in the host guardian service, all I need to do is add a domain controller to the group of domain controllers that I approve of to run virtual machines. And it's funny because if you look at Hyper-V, and I'm going to show you in Windows 10 because the feature is there as well, it's just not that mature because you don't have the host guardian service and stuff like that. A shielded VM doesn't have a thumbnail in Hyper-V, nor does it allow VM Connect to connect to it. And there are certain points that are also of interest because we limited the functionality of the integration components, backup and restore, and snapshots also become kind of interesting. But that's for the third session from Timothy. Let's look at Hyper-V. I got Hyper-V Manager right here. This is my Hyper-V Manager on Windows 10 on this box. I have a normal server and I have a domain controller. And if you look at a normal server, you have a thumbnail right here. You can see what the box is doing. You can see the generation, configuration version, and you can see a heartbeat. Now, I just shut down my domain controller, and that's because I can set the setting in security to enable shielding, which is this option right here. Then all the other options are grayed out and selected by default. And now I can say OK. And now as an admin, I don't have any control over it. I can start it, I can stop it, and that's about it. So now it's starting, it's running. It's not running yet, it hasn't booted yet. You can see it at the heartbeat. There's no contact. But this guy will remain grayed out. And it's almost there. It doesn't take long to start, about 25 seconds. And there you see, the heartbeat is okay. The box is running. Now, if I want to connect to the box, it will say, you cannot connect to a shielded virtual machine using the virtual machine connection. Use a remote connection instead. Well, then I need the admin credentials, and I don't have that. So now, the only way to gain access to the domain controller is through another server, like the 2016 server, which is the second VM that I have. Now let's run MSTSC. And I can just connect to DC1, log on, I don't know, and we'll have the domain controller logged on like that. As a Hyper-V admin, I can no longer do anything with that VM. I have to be a proper AD admin to do stuff with it. And if I BitLocker the drive, then storage admin and Hyper-V admins, no one gains access to it anymore. So it's funny, it's shielded virtual machines, and it's a new feature that is actually reusing BitLocker, reusing all the stuff and experiences in integration components. That is the true solution from a technology point of view. Then, of course, there's the process point of view, because all of that is useless without monitoring, without key management and change management, without auditing, and without communication between your AD admins, your Hyper-V admins, and your storage admins. And it's also useless without documentation. And it's funny because documentation is like sex. Everyone talks about it, nobody actually does it. And of course, you have to have your backup and restore processes using Veeam, of course, and lifecycle management, because you have to keep everything up to date these days. Now, concluding, we talked about domain controllers containing sensitive information. They've got information on replication, accounts, credentials, the entire Active Directory topology. You don't want to have that fall into the wrong hands. And DNS servers is the same. Most environments I know combine Active Directory domain controllers with DNS servers. They contain caches and queries, so visited sites, that can be PII data as well. Virtualizing domain controllers safely is not an easy task. And it's not just a technical challenge as well. You have to look at the people. You have to look at the processes. And I feel you should ask yourself, do you really want to virtualize domain controllers?
Okay, with that, I want to, we'll end the webinar. We want to thank you all for joining in, for being with us so immensely. And then know that we will cover the Veeam and the Active Directory part in the next webinar. So hopefully we'll see you there. Thanks for joining. Thank you, Sander, for this great webinar. And have a good day or a good evening wherever you might be. Okay, thanks. Bye.
Yes. Bye-bye.